Hundreds of thousands of researchers around the world are working to improve life and address imminent threats to humanity. Often their research ends up in the scientific valley of death in the form of publications and patents that never see the light of day. That is about to change. Welcome to the Lab to Startup podcast, hosted by Naresh Sunkara, founder and executive director of the Berkeley Postdoc Entrepreneurship Program at the University of California, Berkeley. This show has two main goals: share the stories of those who have successfully founded startups based on their own research, and highlight resources needed to help those aspiring to launch startups in the deep tech space. Whether it's electric cars, vaccines, addressing climate change concerns, or possibly establishing life on other planets, Naresh and his esteemed guests want to help scientists, engineers, faculty, and researchers bring their innovations to market. Learn more and subscribe today at labtostartup.com. And now, here's Naresh.
My guest today is Mark Brinkerhoff, President of Fusion Design, a turnkey product and equipment development consultancy with over 20 years of experience with industrial design, mechanical engineering, and prototyping service offerings. I was first introduced to Mark around 2015 when I was in the midst of building hardware for my own startup. Since then, his firm helped me build two other hardware products that are currently being used in autonomous mapping for cars and the oil and pipeline industry. One thing that amazes me every time I walk into their offices is the display of patents and the samples of products they helped design and build over the years. It is like a museum in there. They built over 1,500 products, including high-security human scanner, laser eye surgery system, migraine treatment systems, and drones, amongst others. Mark and his team have mastered the art of designing and building hardware products. I could not think of anyone better to learn from on the subject. In this episode of Lab to Startup, we will talk about some of the basics of designing hardware products, which include the concept of design, how to put a requirements document together, lessons learned from prototyping over the years, how to estimate costs and timelines for building a prototype, with an emphasis on iterations that a prototype needs to go through, and how the face of outsourcing is changing in the US. I'm sure you will learn so many things in my conversation with Mark. Welcome to the show, Mark. As I mentioned earlier, most of my audience are deep tech researchers developing core technologies at universities and national labs. Once they have a proof of concept in the lab, the next step is to try to build a product they can take it to the customers. So I'd like to focus this episode on the concept of idea to prototype for hardware products. I know that, again, this is a huge topic, and I'm hoping to do a series of discussions touching on various subjects in the future. So keeping that in mind, let's start with what Fusion Design is all about and the services you offer to early researchers trying to build a product around the research.
We have an offering that's 30 years old now. We've been developing products in the Valley for all kinds of folks, from individual inventors to universities to Fortune 100 companies. These efforts have spanned all kinds of services, but mostly mechanically centric. That includes industrial design, mechanical design, prototyping, which in our case means usually fabrication, whether it's through machining or 3D printing or some combination. Those are typical activities that we provide. So far, we've done over 1,500 products over the years. At any one time, we're running between 10 and 15 active programs in the office at any time. Range of things we do are in almost all major industries: medical, semiconductor equipment, alternative energy, recreational, wearables, satellites. It's a long list.
That's a fascinating list of products that you've gone through. How about this? Let us stick to first principles. Get to the basics of where design starts in the process of building a product. Please walk us through how you approach design and what entrepreneurs should consider.
Necessity is the mother of invention. Most of those who I've seen succeed over the years have found a serious need and then solve it with something. There are lots of examples. The ones that don't succeed as much are usually efforts where there's a technology and they're looking for a home for that technology. It's usually because, in my opinion, there isn't demand for that technology in the marketplace as we know it today. That's typically the approach. So designs typically start with the necessity feature, and then they move to an idea that supports the problem that necessity demands to be solved. Once that's addressed, then concepts and or technologies are brought in to evolve the design in a way that is supportive, right? So our support of that whole process starts when there's a light bulb over the person or group or company's head, if you will. We look at it for its design and manufacturability aspects, and then we formulate a path based on where they are and where they want to go. And typically there's two paths that most companies and or individuals have in front of them. One is a licensing path, where they want to develop a very nice prototype, but it's really not ready for showtime. It just looks like it is. In other words, it might be a solid model that has technology available, but not yet integrated, or that's one path. So the licensure path, it might be a royalty arrangement or something like that. Patenting is almost always involved. And then there's the actual full business model development path. And we've seen both over the years. Typically, small companies or individuals, they're after starting a new company, and our large customers obviously already have them, and they have holes in their workforce and or resource pool, and we help fill those holes. Those are typically knowledge-based or skill-based gaps, if you will, and or they are just not enough people to get the job done. That's how we support the bigger companies. The individuals are often challenged in many ways, and I'm sure we'll talk about that more in a few minutes.
That's great. Let us dig into that topic. Products can be probably distributed into two different classes. One is incremental over the existing product, and the other is the first-in-class products. How would you approach designing these two products if somebody comes to you with an idea? How would you guide them through that process?
My personal favorites for that, I prefer incremental products that are based on paradigms. So our guidance is often driven by perceptions of the marketplace, those in the marketplace. An example of that is when you create a device that does something in an automated way when it used to be manual. I'll give you an example. I put one on our website years ago. Imagine that you have a ladder that you have to climb every day because you're in construction. You have to climb up on roofs, and that's very tiring. It's a long ladder and dangerous and all that. And you want to create a motorized ride to go up the ladder. So typically the way you look at it is, well, what technologies can I do to make an escalator out of my ladder? And nobody's done this, but I think someday they will. But the idea is you look at it from what are the requirements? Well, the maximum weight I want to carry is whatever. And the speed I want to go is either a certain number or multiple numbers. So you can see I'm trying to mature a requirements list. And most people come to us without a requirements list, except the ones that are in their vision. Vision's great, but the requirements must come shortly after. So we guide them in the requirements development. And those requirements come in multiple levels. They come in the marketing requirements activity. We call it an MRD, marketing requirement document. And then that is matured into a PRD, or product requirements document. The MRD is one that is driven by examples in the marketplace. For example, on the ladder story I just told, the market requirement would be get me on the roof in short order. And then the product requirements document would thread to that market requirements document and say, the speed of the motorized step, if you will, is this many feet per second. And it can lift this much weight, X number of pounds. And the power source is a battery, and the battery must be this big. So you can see the market requirements are basic functional items driven by the marketplace and the need. And the product requirements are very specific. And us engineers love that product requirement document because it helps us do the right thing. And it gives us guidance as to what the individual or company wants. So that's our first guidance, is how to do that. Occasionally, people have that, but most often they don't. And they don't either understand it because it's new to them. And so there's a significant education component, and that includes academics as well. Academics are awesome in their space, but when they go to try to get their prototype or their product to market, it's a new space, so they have new things to learn.
I was talking to Walt McClare, a mutual friend from Wohler Systems, a couple of weeks ago, and he was talking about everything boils down to requirements, requirements, and requirements. What makes a good MRD and a PRD?
That's easy, I think. It's hard to do, but it's easy to conceptualize. If it captures the essence of what is needed, both emotionally and physically, in a way that can be translated into a product, then they're great documents. If it can't be, then they'll lead you in a circle or a zigzag on your way to getting those prototypes ready. So I think the fastest way to get to an answer is super clear requirements. Needless to say, most requirements documents aren't fixed. They create them, or we do with them, and then we evolve the design as we learn more about it. So new space, take the ladder example, for example. You may find that the batteries on the marketplace aren't strong enough. So the requirements you had for a certain battery aren't going to work. So what are you going to do? You're going to change the requirements document and say, oh, I need 2 batteries instead of 1. Or I need a bigger battery. Or I don't want to recharge it. I'm going to plug it in the wall. Those are evolutionary steps that happen to the requirements document. I think one of the biggest failing points is that document isn't maintained. It's done once and then forgotten. And that's fine if it's a simple product and happens quickly, but it's not fine if it isn't. And so I think that the best answer is a diligence toward the requirements documentation maintenance.
I've gone through a couple of products with you and I've learned quite a bit about this PRE development, and you guys were phenomenal in helping us get there. What are the general points that are usually missing in the PRE, product requirements document, when an entrepreneur comes to you?
Things that are missing are usually numbers. Numbers. Simple. Yeah, numbers. It depends on the person, I guess. If it's a marketing person who comes, and they often do, then they'll probably be pretty good at creating a marketing document. If they're a technical person in the engineering space, they'll be better at making a product requirements document. But what you really need is 2 individuals, or at least 2 personalities, wear a lot of hats. And so I think that those are the most important things that you can have in these activities. So usually the gaps are, it's misunderstood what the requirement documents are, and then it's poorly defined from a numerical point of view. How powerful should the motor be to lift you up the ladder? That kind of thing.
Interesting. Well, once you have your MRD and the product requirements document, you set out to start building the prototype. Give us a sense of, like, I don't think most people get the product right the first time. It has to go through iterations. What are the typical number of iterations they have to go through to get to a product that they can take it to the market? The reason I'm asking this question is from a fundraising point of view. An early stage entrepreneur who's not experienced might tend to raise a little bit of money, hoping that they'll just build a nice product. But the fact is they have to build a lot of iterations of that. If you can paint some color to that, so that people will raise the money accordingly and set the timelines accordingly, that'll be very helpful.
Unfortunately, the answer is it depends. So I'll talk about the process a little bit. Typically, let's say a consumer product that might leverage a technology developed in a college or elsewhere too, it could be. The process is usually industrial design first with a mechanical design support. And by that, I mean, it's a process that looks at usability, aesthetics, ergonomics, and mechanical function capability. So the beginning of our activity is heavy on industrial design, those items I just discussed, and light on mechanical design in the sense that whatever's being chosen or decided in the beginning of the ID process is supported by real-life design for manufacturability solutions. In other words, if we see, as mechanical design folks, if we see an industrial design doing something that's just not possible or feasible, it's our job to play the role of saying, well, could we do it another way? Because that one chosen may not work. So that's the beginning of our process. Once the industrial design work is done, and there's a significant process there, lots of videos on our site about that. Once that's done, then it's a heavy mechanical design activity where we mature the essence of what was created in the industrial design to a manufacturable solution, whether it's metal parts, plastic parts, lots of electronics, whatever it is. We integrate all that into our 3-dimensional CAD systems, and then we print the prototypes typically for smaller devices, and or we order out parts for larger ones. Largest things we've done are radio telescopes, which you don't just go 3D print those. They're the size of 5 houses stacked on top of each other. And the smallest thing we've done is a stent, which goes in your arteries. The difference between those two, the fabrication methodologies for a prototype is way different. And iteration count is way different too. So what I always promote in the beginning of, you have to pick a project. I'll pick a different project that we did many years ago. It was an exercise device that was for travelers. I thought it was a really good idea. It was basically, it looked like a water bottle, and the water bottle was without water when you go somewhere, and you fill it with water, and it has handles on it so you can do your exercise while you're traveling. So great idea, different sizes. So I promoted that, we did as a whole, that this gentleman who was an athletic trainer build mock-ups. I said, go to Home Depot or wherever you go for your hardware, buy duct tape, rubber, use water bottles, fake it or pretend you know what your product's going to look like and try it. I think he did as many as 20 iterations before he got to something you say, you know what, this works every way I can think of. Let's start here. That was great. So I always promote iteration early, and you might call it failing fast. You want to find out what doesn't work. That's just as important as what does. So you don't end up there in the last part of your development, spend all the money and time and find out that's not the right answer. So fail fast. Successful ones should rise.
Iterate early and fail fast. This is such an important lesson that I learned working with you, and is a great advice for those trying to build. Mark, while the exercise machine is fascinating, can you give an example of a technologically more challenging iteration of a product that you helped develop?
Let me see, about probably 15 years ago, we did an eye surgery machine for one of the world's largest LASIK equipment makers. That machine was highly interactive with doctors, nurses, patients on a minute-by-minute basis with very high-tech integration. It had excimer lasers in it, optics, human support systems, both chairs and beds that had to articulate, and special pillows that support the head in unique ways for LASIK to operate properly. It had air vacuum systems to draw away any effluent that comes from the laser process. Tremendous number of complexities. So before even designing that, we created sketches and physical mock-ups, and we actually built into their building, which is up in Santa Clara at the time. We built a mock doctor's office, and we had nurses come in, we had doctors, real people in the profession come in and use our mock-up. And it was foam core and screwed together 2x4s, and it actually looked pretty real because we spent some pretty good time on it. And we had the space of the office, the right size. Then we had 10 or 20 different pillows that we had available. And we came up with solutions that were driven by the customer. And that was very early in the process. And that was a win. That's the way to do it. Because if you can imagine the cost to develop and iterate after you've done a full design, find out that doesn't fit half the people we wanted, then that's a big mistake. So that was an example of a complex version of what we've done in that space. And I promote this all the time. In fact, now we own 4 different 3D printers, so we can print early concepts quickly in rubber, plastic. Now, we haven't done metal yet, but in many different formats, so that we can say, well, let's try it. Let's try the physics, ergonomics, aesthetics right off the bat. Don't wait.
Phenomenal. I think 3D printing has changed that early stage process and cut down a lot of failures because of that.
Oh, it sure does. Those printers are running almost every day in our office, almost every night too.
Speaking of failures, as someone who has worked with you to design, build, and bring 2 products to the market, one thing I understand is that building hardware is very hard. Even big companies like Google and Amazon fail. The Google Glass, Fire Phone, they're not able to bring it to the market, even with all the resources at their hand. What makes building hardware so hard? Maybe you can talk about what are the common mistakes that you see again and again that these processes are failing.
I think we kind of touched on that previously. And let's take Google Glass. And this is my opinion. I can't prove it, but it's what I think. And when I saw the product, I definitely thought it. I believe that they had a technology looking for an application. They should have had an application looking for a technology or a solution. They wanted to make it easier to interact with the world and a computer at the same time. That's a valid thing to do. But the way they executed it probably didn't have enough market research to support the mass production of a device like that. Otherwise, they would have known before they spent a monster amount of money getting there. I think that the oversight of that is its true failure. I'm not sure it was just the execution. You have to have good execution too, but it wasn't a killer app. It didn't have a killer app. It didn't enable something that the humans just had to have. Didn't do that.
I think that's a common problem we see in academia as well. We have a lot of technologies looking for applications, and that market research, I think that is very key.
I'll give you another one that's just the opposite of that right now. In fact, we just put an article on our website for this. Actually, I think it goes up today, maybe tomorrow. Battery technology. If you look at the investments that happened over the last year, it's crazy how much money is going into battery technology development. And that's not just for cars. It's for all kinds of things. It's for wearables, phones, everything, everywhere. And the amount of folks focusing on the science of that is actually worth it because the demand is so high. Imagine you could buy an electric car that goes 1,000 miles between charges. It's probably going to happen. Maybe not tomorrow, maybe not next year, but it's going to happen. Today, you get range anxiety, and tomorrow we're going to say, hey, now gas cars have range anxiety instead of electric ones. But that's one where the investment's worth it. Maybe Google and others, if they looked at where the market needs are more seriously, and they're probably addressing them anyway, but they might change their path a little bit.
I think that's where the academia comes into picture, I guess. Lots of money is going into R&D, especially around battery technologies, and those need to come to the market as well. There's a missing piece, and this podcast is an effort to encourage them to bring those to the market.
I think one of the greatest examples of market research was what Toyota did with the Prius. I don't know if you ever had one, but lots of my friends did. Those are fantastic. They were the number one selling car in the United States for like 10 years. Why is that? Well, they had 1 foot in the past, gasoline engine, 1 foot in the future, electric, and they got great mileage and they're very reliable. Win everywhere. So they, I think, turned the market toward new technology. And then obviously Tesla came along and pretty much shamed all the other auto companies into doing battery solutions as well. So good for them.
Those Prius, my father-in-law just got one a couple of years ago, and like he loves it.
They're great cars. I love those cars. They make an awesome taxi too, by the way.
Oh.
They're really good. Really good.
Well, let's slightly shift gears. And you touched upon this very briefly about fail fast at low cost. And I also asked about cost consideration when somebody's trying to raise funds. Can you knit this together? How do you fail fast, and how do you plan the fundraising around developing a hardware product?
So most fundings come in phases, Series A, B, and so on. I think the first early phases are often funded by individuals or angels, if you will. And those should really prove the technology. They should come out, in my opinion, with a proof of concept. If it's a hardware device, it should be obvious that this thing is going to work at the end of that, which I think is the best place for initial money. You could project what it would cost beyond that, but don't do it yet until you've proven it. So that Series A or angel funding, which is often before A, I think, those can often be done with proof of concept work. So if you had to tell someone what the total cost would be, then we write quotes for that in their projections. Sometimes it's for moonshot stuff, things that will go into space, and they may never happen. But if they do, we need to project what the cost is so people can weigh the benefits versus the cost. So we do that on occasion, probably 4 or 5 times a year, and we do a budgetary projection of what costs would be for a whole program. And that involves a lot of things, not just design and prototyping, but design, prototyping, supply chain, tooling, testing, all the other things that go into a rather complex product that might be done in the future. That's how we see it.
I asked this question to a couple of my other guests as well. One question that keeps coming up again and again is when you try to pitch to an investor, they'll ask you what is the price going to be? What are the costs going to be? And I think the early stage entrepreneurs do not understand that concept, especially grad students and postdocs. We didn't ever charge too much money from the universities. So how do you respond to a question like that? Like if an investor asks you a question, what is the price going to be? What is the cost going to be? Especially if the development is going to happen over a period of years. What is the best way to answer such a question?
Well, there's 2 ways to look at it, in my opinion. I assume you're referring to NRE, non-recurring engineering?
Yeah.
Okay. Because the other cost model is what fits the marketplace. What will the price of the device or product or thing or process, what will it cost to the consumer or whoever consumes the solution. The NRE part is often pretty tricky. There's two ways, I think, to look at it. One is you look at big chunks and representative projects that you may have worked on in the past, and we've done 1,500 of them. So there's almost always an example product or 20 that came out this way, and this one's probably going to do that too. So the example project as a frame of reference. The other way, which actually works pretty well too, is you imagine the size of the workforce that has to go into it and the number of prototypes and iterations that might be associated with it. Is the harder it is to make, the more iterations you'll probably have. So you look at that and you project all those things and you do it by a manpower point of view. It's like, well, geez, if I had to staff this, that's going to take 4 people. One will be an electrical engineer, one will be a mechanical engineer, another will be a project leader. We need one more in the shop. That's the core. And then for this phase, we need an analysis person or company. And so you look at it from a resource allocation point of view. So that's basically the two paths: resource allocation in your experience, and then just past projects, which have already succeeded.
Having a good idea about resource allocation is super important, and consulting others with experience building similar products is equally important. Those are some great insights into design and prototyping costs. Let us slightly shift gears from fundraising into something more important. Whether it is a first-in-class product or an incremental product, we almost will end up needing a custom part to build. How do you find an excellent manufacturer for your custom parts? I remember when I was working with you, we went to an aeronautical industry vendor who built some precision parts for us. How do you find these vendors to help us build those custom parts?
There's a couple ways. One, the most common way is through experience and word of mouth. You ask a friend, or if you've done it yourself, then you just already know the folks. The other way, which I've had to do more than once, actually probably many times, is if you need a solution that requires the best in class manufacturing capabilities, you go to whoever makes the best machinery that's needed to do such things. You ask them who buys your machine and who makes you guys look awesome with their output. And they always have a proud customer, and they have all the incentive in the world to refer to that proud customer. So you go to that customer and you find out what they're making, and you realize they are the best. And if you can afford it, which often they figured out cost models too, it's reasonable. That's the best way. And I did that for an antenna project. It's a spun metal dish. You see them up on the poles. They're called cellular backhaul. They carry cellular communications from one pole to the next, which can be 2 to 5 miles away. And their parabolic nature allows them to focus the beam across that distance. So we needed a very accurate dish form out of sheet metal without paying a monster amount of money for a precision forming tool. So what we needed was literally a CNC spin former. I hadn't even heard of a CNC spin former. What's that? So we did some fishing and found out who made them and asked who was their best customer. And they referred us to a company in Pennsylvania that makes helicopter parts. And they're low volume, they're high precision, and they're very high quality. Turns out we went over there and said, well, you guys are a slam dunk. Yes, here's the order. And they've made thousands of those things from that. It was great.
So if you need a solution that needs the best-in-class manufacturing capabilities, you just go to whoever makes the machinery and find out who buys the machine, and they'll just be happy to refer to their customers. That is such a great hack, Mark.
Well, and battery technology is very exciting to me. I mentioned that before. Today, you can buy batteries that you can literally wrinkle up like a piece of paper and then unfold, and they still work.
Flexible batteries.
Oh, man.
Those are fascinating. I was looking into some wearable devices. I think Japan is like way ahead of everybody else.
Yeah, they've got some great stuff. I went to CES when you actually could, just before COVID, actually. And there was quite a few there. And one gentleman I think he was from Japan, very nice man. He had flexible batteries, and I just couldn't believe it. He also had wiring that, and this is exciting to me too, wiring that literally could stretch. It was sleeved. So your conductor would be a foot long when you look at it. You could stretch it to 2 feet. It's like, you can't stretch copper without it breaking. Well, it turns out they had a way of doing that, and I think it was all coils, but the way they did it was very nice. So why is that important? When you think about it, if you're doing wearables, flexible batteries are great because the body is not flat, and you're going to probably put something on the body that needs to be curved. Okay, curved battery, great. Well, then if you want to make the body network, which I think is coming, lots of computer functionality in a coat, for example, well, you got to run typically wires from A to B, battery to processor to speaker or whatever you have in there. Well, then they're going to flex and break. But if you have stretchable wiring, then that is an opportunity to make more technology fit in that potential application space. So for me, I love technology and I love merging it into solutions, but we always start with the problem and then we pull from technologies to get to a solution, which brings up another thing that I like to do. It's harder to do, but I think it's very important. If you're someone with a technology and an idea that looks like it's coming, but it's still too expensive for the market to accept, for maybe chips cost too much or batteries, whatever it is. If you can look to the future and say, well, 5 years from now, I can buy batteries that are twice as dense at half the price. This product will be a big winner in 5 years. So plan your development around that 5-year time frame. And then if you also merge that with the demand of the need, whatever it was going to do before, it will now do quicker and more completely in 5 years, then that's the way to win. So you may develop stuff that just isn't feasible today, but is 5 years from now. You have to have patient investors for that, but it makes you first person in. Those who do that are really the winners, in my opinion.
Stretchable wearables are fascinating indeed. I was speaking with Professor Joseph Wong from UC San Diego, who is a pioneer in the space building stretchables with magnetic material, where even if something breaks, the magnetic activities sticks them back together. They're doing some amazing research on those material.
Love it. I love it.
I hope we can get to work with him one of these days. But blend the current and future trends to see future intersections of tech and societal interaction with hardware. Arthur Clarke says that any sufficiently advanced technology is indistinguishable from magic. Do you see anything happening in that space? What do you think is the next magic is going to look like? We don't see motors anymore, but they're all over the house. We don't talk about it. That's magic for us. What is that next thing going to look like for you?
I always wanted a holodeck. To me, all my friends know this, my favorite thing on the planet, which to me is magic, is magnets.
Magnets.
Magnetic fields can do things that appear completely impossible, and they just work. And they keep working, and they don't lose energy, significantly. A magnet is a magnet. It keeps acting like a magnet. Yeah, you can break them, but they don't wear out. Even a spring wears out. Rubber wears out. Clothing wears out. Everything wears out. Magnets don't wear out. To me, that's magic. I think that application of elegant mechanisms using magnetic technology is the magic of the future. You'll be able to create devices that mechanically help humans live better lives that never wear out, because you've got magnetic bearings, magnetic actuators. It doesn't have to be all magnetics, but the point is, I think the magic of the future is based on technology that we really haven't fully exploited yet. I think for me, that's awesome.
Are there universities or geographic areas around the world that are ahead in making hardware products that you see, like micro hardware?
I was looking at the battery technology just the other day, so it's on top of my mind. They're putting batteries in all the major formats that work with today's electronics. To me, that's a form of magic. For example, imagine today when we build a circuit board, we put chips on a circuit board, and those are done with automated machines that are so fast you can't even see them move. They're like machine guns, they're so quick. So now they have batteries that can go in those same machines. She could literally load a circuit board full of little square batteries that are smaller than a quarter of a dime, and they solder into place just like that. It's incredible. I like to see how technology makes things better. Now, one of the things most people miss, if you take a blue sky approach and you evolve a technology that doesn't have a foundation like a circuit board in today's world, then you run very high risk of running out of money and or time to solve that problem. So I always like the incremental steps rather than the revolutionary ones. I think the revolutionary ones can come from those who don't have to make a profit for a long time. And big companies like GE, they have their own research groups that do that all the time. And every once in a while, they'll spin tech into their core product set, but they've already vetted it to the degree where it's ready.
Yes, revolutionary products can come from someone who does not have to show profits for a long time. SpaceX rockets, magically VR glasses, they come to my mind because they don't have to show profits for a really long time. I agree that for most entrepreneurs trying to build new hardware, it's better to take that incremental route. On that note, let's talk about a topic that is on most people's mind nowadays, outsourcing. Post-pandemic, what is outsourcing looking like for entrepreneurs trying to build products in other countries?
Yeah, I watched COVID early on. We were doing a very big project for one of our Fortune 100 companies. And we wanted something that was normally off the shelf. You get it in a couple of weeks. And it didn't show up for 3.5 months. God, we were upset. So the supply chain just went down because all it took was a few absences in that chain of events. Supply chain is a really good name. It's a chain of events that has to occur to deliver you something you need, whether it's your product or a piece of your product or something like that. I think that was a monster challenge, and it continued to happen. You see it now off our coastline. It's awful. Bunch of ships and just sitting there, and they're dragging our oil lines with their anchors, creating oil spills off the coast. Really sad. But today, honestly, I order things from rapid delivery services, Home Depot and Amazon, lots of different places, and they're still doing really well. So I think what's going to happen, and it is happening, is we're going to create a more redundant, resilient system. I think even the U.S. Postal Service is going to do that. I'm starting to see them buy new vehicles after like 40 years of the same delivery trucks. I don't know if you've seen them, but I've seen them. It's like, how are those things still running? I think that the evolution of the supply chain is going to become one of greater resilience. The other thing I think is going to happen is local sourcing. We've always tried to source from a distance, Mexico, India, China, whatever. I think we still will. But with the barriers, not only time, but cost, which is way up in both cases, the effectiveness of local sourcing is going to become greater. And it is. So if you're a designer or someone with an idea, if you can figure out how to get that idea built with local technology. Now, local might mean if you're in Europe, it's in Europe. If you're in China, it's in China. If it's in US, it's in US. Local sourcing. But I like that a lot because it allows you the flexibility to make a living and or a solution that's cost effective for you and your customer in a local sourcing way. And it takes out a lot of supply chain challenges. I think that's the future.
Local sourcing indeed might be the path forward for entrepreneurs trying to build hardware products. On that note, Mark, any closing thoughts for those taking the leap of faith to build a hardware product?
First one, it always costs more than you think it will.
It does.
Yeah, always. I hate to say that, but it does. For lots of reasons. There's a long list. I think the other thing important is take it as far as you can, as deeply as you can, and document your requirements before you even start a full development activity. Make lots of failures. Fail fast.
Those are such important lessons. Just to summarize, it always costs more than what you plan for. So try to be thorough with documenting your requirements before you start building, and fail fast. Mark, this has been so much fun and tremendously helpful for me, and I'm sure for the others listening. I hope to bring you back for more discussions on product development in the future, as we just focus on the idea to prototype phase in this episode. Thank you so much for doing this.
No problem.
Thank you for listening to this episode of the Lab to Startup podcast. You can find links to the resources and programs mentioned in these episodes, connect with Naresh, or subscribe to this show at labtostartup.com.